So, okay. Well, thanks everyone for joining this. Maybe just a quick kind of background of myself and what we plan to talk about. My name's Eric Green, and I'm a research engineer with Kentucky Transportation Center at UK. And we've developed a tool called SPF-R, and it's a tool to build SPFs using free open source software called R, particularly R Studios that we'll use today. And I'm going to kind of walk you through how it works, and Hussein's on the line too, and I encourage you to chime in at any point, Hussein, because you kind of went through this process, a year ago, right?
Right.
Yeah. So, and Hussein's with Iowa DOT, or I'm sorry,
Iowa State.
Yeah, Iowa State, but you work with the DOT there,
Yes.
similar to how we do. And looks like Nathan joined us from Transportation Cabinet, and he is our DOT representative who has used a lot of the results from our SPF development. I am recording, Nathan, so apologize to give you a late heads up there.
That's all right. I just hopped back in from a project meeting now. I just hopped in to listen and learn as well. So.
Okay. And Christy, who do you have with you?
I have Caitlin Ruka. I'm going to let her introduce herself.
Hi, I'm Caitlin. I'm just started as an intern at the Oregon Department of Transportation.
Can you hear us okay?
Sure can. Yep.
Okay. Yeah, so I'm Christy McDaniel Wilson. I'm the State Traffic Safety Engineer with Oregon DOT.
Great. And my understanding is you're wanting to develop SPFs for intersections, correct?
Well, we are interested in the SPS, but also the R code behind how you do the HSM predictive analysis on intersections.
Right.
Yeah, so two pieces that we're interested in.
Okay. Well, great. Yeah. Well, I think that's what this will cover, and I'll leave it to you to control my pace here, but I'll kind of go through at kind of a high to mid level detail, and if you want me to kind of dive in deeper on anything, you let me know.
Okay.
Let's see. So away we go. Unless there are any questions, restart. I'm gonna share my screen here, and I'll switch back and forth between kind of some notes here, RStudio, and then Windows Explorer, so you could see kind of the output and how things all shake out. So to get started, and I emailed these links, I think, to everybody on the call. This will get you started with the software, and everything's free, everything's open source. There are other versions or other IDEs for R that you can use. Certainly, these are just what I'm familiar with. So to start, you need kind of the base core, which is R, which you may already have if you're familiar with R, and you can get that from the first link, rproject.org. And then I prefer using RStudio. It's kind of a nice GUI IDE interface for R. It has some debugging tools I find very helpful, and that's kind of what I'll show here. Just full disclosure, I'm not an expert in R. I'm more of a Visual Basic .NET developer, but I think we have enough examples in what we're going to do for SPF development and predictions to kind of follow along.
Eric,
So, yeah.
Are your libraries specific to a version of R or RStudio?
As far as I know, no. I've been using the same code and libraries for 4 or 5, maybe or more years, at least in RStudio, 4 or 5 years. And as RStudio has updated, I'm still using the same libraries. And in fact, as I'll show you, it's even gotten easier.
Okay.
But if I ever notice some hiccup with a certain version, I'll try to note that so that people are, cannot update. And I always have archived installers for this. So if R ever updates, you know, we can always roll back to an old version. But yeah, that's a good question. Not as far as I know.
Okay, thank you.
And then RTools is kind of a larger package that I do use. So that needs to be installed as well. Again, savvy R people probably are familiar with these tools and or may already have them. So those first 3 links need to be downloaded and installed. And I don't even believe it matters what order you do it. So just make sure those are all installed. The next link is the GitHub repository for the code. As I make updates to SPF-R, I post it here in GitHub, and that way, if there are any bug fixes or enhancements, it's all kind of in one place. I try to keep a version number on this, but I get pretty lazy with updating that. So generally speaking, if there's a major change, I'll try to get it here in GitHub. But you can pull a version of this down and modify it to your heart's content. And if you find something valuable that you want to add, I'd love for people to commit to this. That's helpful too. So feel free if you're into that kind of community open source world. But this site is github.com/erkgreen-SPF-R, and here you'll find not only the R code that we'll be using, but also a PDF that was actually put together in great detail, explaining line by line what everything does. Now, again, there are some slight changes that may occur as we do updates. So I'm not updating the PDF with every major change, but you can use this as kind of a guide. And again, it's kind of line by line. It goes over the prerequisites needed, the required packages, but I'll explain that in a moment. And then again, just for each line, it kind of explains what each section does. So I might refer to this as we go forward. But this is a handy resource that I think I emailed to folks, but also on GitHub. So with that, I do kind of prefer RStudio over just using R. One of the neat things now is if you paste in or open the .r file in RStudio, it actually detects any missing packages and asks you if you just want to install them. So normally, according to the PDF, you had to actually go through and install the various packages here by typing them in and comma separated and installing them. But now it just detects them and you can click the install button. So this is fairly recent, I noticed, with a newer version of RStudio. So in general, the PDF can be used, you think of painting by numbers, you can use it kind of coding by numbers, even if you're not very advanced in R or very advanced in statistics or SPF development particularly. You can use kind of the code examples in the PDF to kind of code by numbers. And as I go through, I'll show examples of different ways to implement different functional forms for SPFs, intersections, segments, and that kind of thing. And I'll just show you examples that I think most people will be able to kind of pick up the relationship between the two and kind of customize it on their own. So hopefully that'll be helpful. Any questions before I start diving into showing some how it works and walking through the code?
Quick question. I'm trying to follow along on my RStudio. Is there, so I have to download the code from the GitHub and then import that into RStudio?
A couple ways. You can, if you download the .r file from GitHub, you can actually just save it and then open that file within R. It's not even an import-export situation. It's an ASCII file that you can open in R. So yeah, if you want me to pause for a second so you can get it loaded. Did you already have RTools and, well, I guess RTools would be the only other thing you'd be missing.
Yeah, I believe that I had IT check my laptop yesterday to make sure I had the most current version of RStudio and R downloaded. So I think that I have RTools. I can check as soon as it.
Yeah. You might check, because that it isn't a prerequisite to use R or RStudio, but I think it's a bunch of packages that I'm using, and I forget at this point why I needed that. But for one of the things I'm doing, it required it. It might be the negative binomial regression piece, but yeah, you may want to just, well, I guess you can try running the code, and if it balks at us, we can get RTools installed.
Yeah, no, they didn't install the package RTools. So I'm going to make a note. I just did a library to pull it in, and it says there's no package. So.
Yeah, and I don't fully understand the distinction between the packages, the smaller packages, like the plot package or the OpenExcel, but RTools is a much bigger kind of package that I think is kind of all put into one installer. So this one you actually have to install. Up to you if you want to go ahead and download and install that. I can pause or go into some other detail. Up to you how you want to proceed.
I'm trying to install it. You can go ahead and keep going, and we'll see what happens.
Okay. Yep. No worries. All right. So I have 3R. Oops, I didn't intend to do that. 3R files open at the moment here, and yeah, this is the one is going to just show kind of the basic usage of R for network screening or for segment analysis. Another one specifically going to look at intersections, and then the last one's going to look in more detail at roadway geometry, which we can go into as little or as much detail as you want on that one, because it isn't intersection based, but it really shows you the power of R in eliminating what's called omitted variable bias, which I think is one of the strengths of this tool. Networks or intersections or segments. So I'll kind of go over these three, and again, you can ramp me up or down on what kind of detail you want for each. So let's see. I mean, you can even open your R files in something like Notepad++ and write the code there, and then compile it or run it through through R or RStudio. But again, I kind of prefer RStudio as the interface, because it has some debugging tools that really help if you run into trouble. So the first thing I was going to show is just the basic way to run R or run SPF-R, and this is applicable to intersection segments. Basically, kind of the same features apply. There's a lot of code in here that we won't even touch or need to touch, and that's a good thing. There are only certain spots that we need to kind of plug in and make sure we customize to our data. So that's kind of what I'm going to focus on. But if you want any more detail on any of the other lines of code, you can either look at the PDF that's in GitHub, or just stop me and I can explain sections of code as much as needed. The main thing happening in the beginning is we're loading in these libraries. These libraries aren't necessary for everybody using R or RStudio, so we're going to pull them in so that we can have access to Excel files, make plots and things like that. If you like, and if you plan to use this code for a variety of projects, you can version it by putting in just a version number there. This version number is printed out to the output file, the Excel file. That way, if you ever trying to trace back, what version of SPF-R you use to create the output, it'll kind of tag it with this. So that's just optional if you want to track it that way. And I especially find that useful if over the years you may change the way you're computing your SPFs, and this way it'll kind of tag it with what version you're using. Probably the most important piece that we'll deal with today is the input and output folder paths. So if you'll notice, we're using forward slashes here to define folders. That's just the convention with R. So if you copy and paste the the path from Windows, you'll have to swap your backslashes with forward slashes. At least that was an issue early on. It may be resolved by now, but generally I stick with forward slashes here. I point to the CSV, that's going to be our input file. Eventually we're going to output it in Excel so we can look at it in more detail, but the input file we're dealing with just needs to be a CSV, comma separated file. Obviously you can use Excel to build those. And really you only need, at a minimum for segments, you need the crash column, so whatever columns representing the number of crashes, the ADT column for your traffic volume, and then a length. If you're dealing with segments, we won't need the length, but we might want a side road ADT. And I'll show an example of that in a minute. This is just to kind of get your feet wet first, trying R. And then for me, I like to have kind of a series of filters. You can filter your CSV file manually. So if you're just looking at, let's say stop controlled intersections with 4 approaches, that you might filter that down in your CSV and then use that as your input. That works fine if you plan to do few intersections, but if you plan to do several or dozens of intersection types, I find it handy to put them all into one CSV and then tag each record with the type of intersection, and then we can filter it iteratively. And that's what we've done in Kentucky. And Hussein, I believe that's what you guys did as well. Do you remember offhand how many intersection types you had?
We had initially 20, but we tried to reduce that. Now it's going to be about 16.
16. Okay.
I'm sorry, I was just going to ask, on the right-hand side under global environment, that's your CSV setup. Is there an example of that on GitHub that shows what all of the additional columns you have in there, the data?
I don't believe there's an example on GitHub of the input file, because really the input file can have any fields you want. The environment variables here, this is just because I ran the program, and these are all the variables that were part of it. So this actually has nothing to do with the CSV. The CSV only need the 3 columns listed here, and you can have any other columns. You can have them in any order, as long as they are strictly, comma separated columns. You just need a crash column, an ADT column, and a length, or crash, ADT main, and ADT side.
29 through 31. Okay. Thank you.
Yeah, and then here's where you just specify the name of those columns. Now, again, the vision for SPF-R is to have a web tool that lets you upload a CSV or Excel, and then have you pick the columns that you map them to the right corresponding fields in the model. So yeah, generally speaking, just any CSV will work. I personally like to have one single CSV file, and then I can use R to kind of filter down whether I want to look at this intersection type or this roadway type, or anything like that. I do find it handy to have just kind of a base filter, and just to be safe, generally you want your length to be more than 0, because that's ridiculous to have a 0 length segment. But for ADTs, you might want to eliminate any segments or intersections that have a 0 ADT. Again, that'll just kind of mess up the model. I like to do this because it gives a starting point for the filters, and then that way you can add real filters on top of it. So the length or ADT greater than 0 is just kind of a safe check. And then beyond that, I can show you how you can add different filters to help minimize what I call what I referred to before as omitted variable bias. But I'll mention that one in another example. So again, just point to your CSV file, and here I've created an ODOT demo folder, and then I'm pointing to the segment CSV file. And then for the output, I'm going to put it in the same folder. And that way we can see the input and the output in the same spot. If it's helpful, I find, to kind of name your data. And again, this is used to trace back to the source. So this is just an exercise we did at TRB. So I just called exercise 2. But here you could do, put the years of that the data corresponds to, or if you're looking at certain types of crashes, you could put that in there, or anything of that nature. Again, you want to specify your crash column, AD column in length. Here's just my base filter, but we're not going to really do any filters here. Next, what's happening are just some error checking. So nothing worth diving into here, unless you're very interested. The last thing that's happening here is basically this is an entire function that is run potentially more than once. So it's all wrapped up into something called run SPF. So this actually gets loaded in to memory, and then it gets called later, and it can get called more than once, as you'll see. So just to skip over it for a moment, the last thing that's happening here is that we're checking to see if you want to loop through any what I call classes, and this is perfect for intersections because you may have 16 like Iowa, or I believe we have like 37, 38 intersection types in Kentucky, and we're going to just loop through each one of them. So we have one CSV file, and then we'll get multiple outputs, and we can do that for classes, and we can also do it for injury severity, as you'll see. So that's really the main kind of flow through of the code. The meat of it is inside here where it says run SPF. And I'm not going to go through this line by line, but I will point out some kind of the important pieces. Here we're specifying the variables to associate with the SPF. And since we specified them above, I'm actually using those variables here because the idea is we don't want users to have to alter any code that they don't have to. So generally speaking, you keep that minimized. You're just dealing with setting your inputs and your output, and then you're running the program and it goes. So you're not actually getting into this main function just because it may, mess something up. Unfortunately, if you do want to do kind of advanced analysis, you do have to get into this part of the code. And this is where things can fall off the rails if you're not super savvy with R. But I have so many examples that I think, again, you kind of code by numbers to get it working. There's a little bit of detail in going into adjusting the SPF functional form. But again, in the PDF, here I show the functional form in kind of analytical notation. So like you would see in the highway safety manual, and then next to it, the associated R code. So again, if you kind of paint by numbers here, if you wanted something to look similar to this, you can go look at the associated code here. And this really gets into natural log identities and some mathematical operations that may seem a little nuanced, but they can really affect your the way you model data. And the one I assume you'll be most interested in is the intersection model. And this is where you'd have a major ADT and a minor ADT. And then I keep telling myself I need to pull the length off of the example here because it's not actually in the R code version. It was a copy and paste error. But so that's what we'll focus on today. But I just wanted to get this to run first so you can kind of see how it works, and then we'll try it on some intersections. Does that sound like a good plan?
Yeah, I just had one quick question. How did you determine that ADT was the only variable you needed for a factor? I mean, we did look at an SPF for intersections a couple years ago, and it looked a little different than the HSM SPF, and in that it basically looked at ADT and speed, and it wasn't widely accepted because there was concern that there were other factors that helped it, determine the predicted safety of an intersection besides just those two. So how did you determine just ADT?
Well, I'll tell you that's there are a variety of reasons for it. Well, one, it was based on part of it was based on data availability. We didn't have skew angle and some other factors that we thought might play in. We just didn't have the data.
Okay.
But we had ADT and then side ADT. Speed limit, yes, probably comes into play. The thing I think is very helpful with SPF-R as a tool, especially if you use it as a instead of just plugging in one equation and running it and dealing with it, as we've experienced and in Kentucky and as Hussein's experienced in Iowa. And again, I've mentioned, I think you had better luck in Iowa building the models than some of the ways we did in Kentucky. But there is a near immediate feedback loop running the tool and then looking at your models. So you can detect what you're talking about is, here's a model that's going to predict crashes at intersections. Are we missing any variables that might help predict crashes? That's what's called omitted variable bias. You can detect that using what's called a cure plot. And that's what I'm going to demonstrate today, how you can put in a model without a bunch of variables that might be helpful and see a poor cure plot. And then as you start filtering or you enter in variables that might help the prediction, the omitted variable bias goes away, the cure plots get better. And I think just as a rule of thumb, having a good cure plot and having some goodness of fit metrics, I think that tells you that you've got the right variables, because what you might have in Oregon might be completely different than, Kentucky or Iowa or some other state. So you may find that speed isn't that much of a factor because it might already be explained by some other a factor in your model. For instance, functional class or type of road. Like if the roadway is divided, you're more likely to have higher speeds than if it's undivided. And we already filter by those. So could be that we're doing speed as a proxy. Does that make sense? Or
yeah, that's helpful. Thank you.
Okay. And again, I'm not sure that we have the best model out there. Again, I was jealous of Hussein's cure plots because they looked a little better than ours. But I think you can constantly improve the process by doing an iterative exploratory modeling like this. So, but please keep the questions coming. I think they help, and they'll help other listeners too if others decide to use this. So again, this is just for segments quickly. I know we want to focus on intersections, but I did want to at least run this for our segments. So here is the folder for segments. I did create another version of this, which is looking at variable dispersion. I think this gets a little too academic. What we're talking about here is there is an option in R, although it's a little complicated to implement, where you can, instead of having a constant over dispersion parameter, you can actually vary it by length or some other factor. I've seen this help models in some cases and not help in others. So it's something you can try. It's explained in the PDF with a slight caveat with R. It seems to be a bug in the way it calculates it, but it's easily repaired. So if you want to get, real advanced, you can look at variable dispersion, but I'm just sticking with regular constant over dispersion. And here's our CSV file. And the way I've set up this R is the output is in the same folder as the input. And as you'll see, that makes it really nice for exploratory modeling. So I usually leave this folder here. I'll minimize us here. So this is the folder where the output's going to go. And here's our RStudio. And you may have your own way of running and debugging. I like to Control A and then Control Enter. That highlights everything and that runs everything. So immediately what you'll see in the console for a small data set is saving 7x7 image, saving 7x7 image, and then it'll usually give you a finished note. The reason this happens is we create two plots here. One is just a scatter plot, which just shows your crashes and the SPF by crashes per mile, and just a way to kind of visualize your data. But the more important piece is the cure plot. And if I open up this here, and I'm going to go full screen, there's a lot more detail about cure plots and modeling in some federal highway documents that have been put out in SPF development. I have a little detail in the PDF on GitHub that gets into it. I think I link to the SPF development guide. So if you want to learn more about cure plots, you know, we can have another conversation, or there's some resources from federal highways that get into this. But basically what you want is you want it oscillating up and down, and you want to stay between the blue and the green. And you don't want to see any drifting down or drifting up and that kind of thing. So it's a real nice way to kind of visualize your data instantly. And what I find even especially useful is when you run the model, if you have your Windows Explorer set to show large icons, or I guess in this case we can even do medium icons. Yeah, okay. Not for my eyeballs, I'm afraid. Here we go. So you can kind of, you're just using the thumbnails, you can just glance at the output and say, oh, that's no good, or oh, that's great, and not even have to open up the files and dig into it. Hussein, I don't know if you experienced that when you were doing your modeling, but feel free to share. So,
yeah, well, yeah, that's I did the same thing. So it's cool to see all this when you just get your outputs in the folder.
And I'll show an example of rural 2-lane segments where you can really have a bad model and show how quickly you can kind of hone in on a better model. And the same thing can happen with intersections. I just have more data for roadway segments, so it's a better demonstration. But the more data you have for your intersections, the better you can do to either filter. You do two things to eliminate the bias. Either filter your database, so split it up into 2 sections, or use CMFs to adjust. Or you can add variables to the model, which I think is what you were alluding to, Christy. If you can have more variables in the model, I find, yeah. So those are 2 ways to target this.
Okay.
But you don't have to add something to the model if you could just bisect the model into 2, you know, rural, urban, or divided, undivided, or, you know, skew angle is a good one to enter into the model, unless you had, like, you know, anything between this angle and that angle is in the model, and everything else we'll use a CMF for.
So you could just keep splitting it up by rural, urban, or 3-legged, 4-legged. You could just keep partitioning it and running the code one more time for those separate intersections.
Correct. Yep. Yeah. And what you'll see is you'll start to see a trade-off between a better model and a worse sample size. So, and then we have a graduate student working on her dissertation on this topic, but basically how much do you filter to, your model keeps getting better, but your sample size drops down. So you kind of have to find that inflection point of when do you just stop filtering and say, this is an okay model, but it applies to more miles of road.
Is there a minimum number of intersections that you should never go below?
Well, that again, yeah, I think the Highway Safety Manual has kind of guidance on that. I think we'll see. Well, actually, when you open
it's
up,
100 intersections and 200 crashes for the period of the analysis.
Yeah. Now, here's the thing. Those are guidelines, and I think they're fantastic guidelines if you're completely blind. But if you have access to tools like this, I would say if you had 50 intersections and you had a cure plot that looked like this, I don't think there's a magic number. I mean, I think if your model looks good and your over dispersion looks good, you know, I think it can be okay.
Well, Eric, I experienced when my sample size is low, the over dispersion almost every time is really bad.
Really bad?
Yeah.
Yeah. So if you have a low sample size, but you still have a good over dispersion, I think you're in that safe zone.
Yeah.
I was going to say we tried to do some calibration for the freeway segments, and we ran into issues with sample size and never got a real definitive answer. on how to move forward. So we ended up not being able to finish our work because we just didn't have a large enough sample for everything that we wanted to do.
Right. I think that's where you need to consider loosening the filters and going with more CMFs to adjust. So you could get your sample size up by saying, well, let's forget about lane width and instead use a CMF to adjust for lane width after the fact. But that can be a whole nother ball of wax to deal with too. So, and again, stop me at any point with questions. I'm just on demo mode, so I need steering sometimes. So we ran this code. It produced the 2 plots, and it also produces this Excel output file. The first tab gives us our goodness of fit metrics. These are really handy in comparing multiple models. There's a modified R squared, which doesn't need to be, close to 1 exactly, but as you develop different models, you can pick the one with the highest R squared. This modified R squared can actually be over 1. I think that indicates overfitting in this case, because it's not truly an R squared like it is in linear regression. These other metrics, they're all described in the PDF, so I won't go into huge detail, but there's some guidance here. And this isn't a decimal, so not a percentage. So we're under a 1%, which is really good. And that you can see right here, how many dots are outside of the green and blue. Very few here, and under a percentage, and that's good. You want it under 5. This is just how much it's deviating. Again, more detail on this in the PDF. I do use theta with this. Theta is the output for R for over dispersion. So that's different than the Highway Safety Manual, which uses K. Theta is equal to 1 over K. So when you hear people say you want a low over dispersion, they're talking about K. We want a high over dispersion because we're talking about theta. A little confusing. It's just how R does it. In any event, you have your metrics there, and then the other tab shows the data. Now this might be the piece that you were also interested in. So quick explanation what's happening here. We have our original files for input, the total crashes, ADT, and length. In some cases, we can apply CMFs or adjust for different lengths of time frame. But by default, we're skipping those. What happens here is for this segment here, it puts the prediction in. That's literally taking the ADT, the length, plugging it into the SPF equation that we designed, and putting the result there. We calculate the residual, which is the difference between the prediction and the number of crashes that observed. Then we do cumulative residuals. This is done, again, described in the PDF, but it's the process to get the cure plot. So this is just kind of left over so if you want to go check the values. The last 3, I think, are the important pieces if you're trying to do network screening. We have a weight, which is described in the Highway Safety Manual as taking the observed crashes and the prediction and coming up with using the over dispersion, coming up with a correction for the observed crashes, and that becomes what's called our EB estimate. And we just basically weight based on how much over dispersion we weight between the model and the actual observed crashes. That gives us our EB estimate, and then from there we can calculate what we call, we've called in the past PCR. In Kentucky, we now call it EEC. It's basically the difference between the EB estimate and the observed crashes. And it gives you the kind of one number that you can associate with this segment or this intersection that you can rank by. So if you sort your results here, yeah.
Sorry, Eric, you said, what do you call it right now?
We're calling it EEC. instead of PCR, potential for crash reduction is what we called it for a while. But I think
Right.
as a way to better characterize it, we call it expected excess crashes, and that was just a better way for us to market it to
Okay.
folks that were using it. So whatever term you want to put in here, call it whatever works best for the users.
Okay.
A negative.
Oh,
Go ahead.
No, I think you were starting to answer the question I was just about to ask, which was the difference in the sign.
Right. Okay. So a negative value means basically we could go visit this site and we could shorten the lanes. We could make the shoulders more narrow, make it curvier because it's too safe. And that's obviously a joke. But a negative value says we are seeing fewer crashes than we would expect. So we don't need to do anything to this site, right? It's operating above average, basically. If we go to the other end of the extreme, now we start to see numbers where in this extreme site here, we've got a mile segment with a fairly low ADT of 3,000, 22 more crashes than we would expect. Now, if I was a betting man, I would say there's probably some bad data at this site. It's possible that, for this 1 mile section, it says 35 crashes. There may be crashes are plotted there incorrectly. You've got some mile point or lat long issues, possibly, or it's just a really dangerous section of road. It could have a really bad curve and a bad intersection in that 1 mile segment. So this would be used as a screening tool to say, hey, something's up here. And in Kentucky, and Nathan can chime in because he uses this data, but we typically sort by this and kind of target the highest EECs on our way down. So
just to reiterate what you're saying, Eric, is for intersections, we take the KA, the B, the C, and the O, the screen that you do for each individual one. We put like a weighted value to those excess expected crashes to do our kind of like ranking so that one screening value doesn't outweigh the other. So you kind of factor in all of the screening values.
Yeah. And again, that's a nice way to take the results and kind of cater them to your needs, because just targeting all crashes doesn't necessarily go after the most severe ones. So and I'll show in the examples coming up, I'll show how you can factor in severity as well.
Hey, Eric.
Yeah.
I could be wrong too. If before the R script allow you to do that very easily, the various screening methodologies for each crash, correct? I mean, it's basically streamlined this very well for you. Right?
Sure. Yeah. And then I'm going to demonstrate that with, I didn't have that data in exercise 2 or for our intersections, but I do have it for the last example I was going to use.
Eric, are these exercises that you have available online somewhere?
I think they were shared to the TRB attendees. I believe because this was something VHB put together, the CSV file. I believe I got the okay to share it before, so I can share the R code and the CSV. I would think without trouble. I'll make.
Oh, thank you. We really appreciate that.
Yeah.
Eric, one question. If
Yeah.
you don't have the minimum required number of crashes, so would that still be okay to run the model?
Again, I don't think a minimum is a good metric to decide how many crashes you need. I think a better metric is looking at goodness of fit and cure plots. In my experience with Kentucky's data, even when we first started this many years ago, even really, really bad models, because we went back and looked at them, are much better than using critical rate or some other
That's right.
less science-based method. So yeah, you can have low sample sizes or poor models. I would always just have an aim to constantly be getting better and improving. So it's I wouldn't say just put garbage in, but having using an HSM process to get at targeting high crash locations, I think is better than some of the other methods. So
Right.
yeah. Even if you're not hitting the minimums, just look at your cure plots. That'll tell you.
Okay.
Yeah. Okay. So I'm making a note there to share the exercise there. Let's see. So the next example gets into intersections, which I think would be more useful here. And I'm just going to do the same thing. Basically, I'm pointing to the classes folder. Classes is just the term I use for loops, basically. So if we look at our input file, let's see here, input folder, so classes. And now saying this is your Iowa data, right?
Yes.
Yeah, and I got the okay to share it.
Sure.
I hope that's still true. So, and then here you have class 0, class 1 through 38. So this was your original iteration.
Yeah. Originally we had 38. Yeah.
Yeah. So here we just have an intersection ID, a class, which again is just an integer between 0 and 38, major ADT and a minor ADT, and then the number of crashes. So perfect database to use. Now, of course, you could have, as Nathan was saying, you could have a K column, a KA column, a KAB, a KABC, and so on. If you had those, you could use SPF-R to kind of look at severity. But I'll show that example in a moment.
All right.
So just looking at, we're going to do the same thing we did before, but now point to the input, point to the CSV. Where's your output going to be here? In this example, I actually just take your input folder and your input file and then concatenate them using the paste function. And then the output, see here is just leftovers from previous code. So this would be Iowa, DOT, intersections. And again, if you label these correctly, you'll go back later and have a nice record of what you use. So I might say intersection crashes, 2013 to 2017. Sure, it was probably newer than that, but that's, again, this is just for example. Oh, okay.
Yeah, that's
yeah.
correct. That's 13 to 17.
Yeah, look here. Actually, I had already done this. So,
Okay.
so it looks like what I'd done in the demo is I just, even though I defined them here, I just copied and pasted and defined them again. So again, you can kind of paint by numbers here and see different examples, but there we go. The column that had crashes was titled crashes. The ADT column was titled major ADT. The minor ADT is called minor ADT. I commented out the length. We did point to the intersection ID, but I don't think we use that in the model because that would be pretty silly. I think I'm looping through 22 and 23. So this will create a model for intersection 22s and intersection 23s. I'm not sure what those are, but assume they're two distinct types of intersections. So obviously you could set it from 0 to 38 and it'll run the whole model or the whole database, but that takes a while. So we're just going to do it on the 2. Again, we have filters here. You may want to make sure your main and major and minor ADTs are not 0. But I'm going to get into filters on the next example. Again, we've got our kids. The only trick here is we had to modify our SPF equation to factor in our major and minor ADTs, and we threw out the length. So this is kind of mirrors what we have in the PDF. Of course, if you wanted to expand on this, add a skew angle or something else, you can do that. And I do try to show examples of how I've integrated different model parameters. It gets a little tricky when you're talking about whether or not the factor has an exponent or not. The e to the a is always our offset, so that one just I'm sorry, it's not our offset, our intercept. That just comes out of the model automatically, so you don't have to do anything special for that. But the length, if you don't want an exponent on it, you treat it as an offset. So you can see in these two examples here, length is not the same as ADT because it doesn't have an exponent, but here length does have an exponent, and it's just like ADT in the modeling equation. So again, paint by numbers here, you can kind of see different ways of doing this. You could add a parameter pretty easily to intersection, such as skew angle, similar to how we do here. And again, you can try these out and look at the cure plots and see how they work. In fact, there's one really nice feature of Excel here where I'll show you how you can check to see if you did your modeling correctly at the end. So I think everything's set here. I may go ahead and run this. Again, I do Control A and then Control Enter. It's going through there and then saving the image. So you see it creates a class 22 folder and a class 23. I noticed there's a new convention now where it's asking us to refer to a column differently. I'm not sure that would work in our context because we use a bunch of different tables. So it's just a warning. I think you can safely ignore it. It didn't happen in previous versions of R. So here you can double click your 22 folder and look at your cure plot. There it is. Now we're starting to see it a little jumping outside. And then we have our Excel. I'm going to look at the other one here. Okay, so a little bit outside. So not as good as what we saw with the other example, but it's my understanding that Iowa has done quite a bit to improve this, maybe for these classes, but that's how you look at it. And then you could go make changes to your model or make changes to the filter and then run it again to see if it makes an improvement. And again, you can open the Excel file. Here, I think I noticed I had a slight bug in our output of the previous because we had beta 1 and beta 2 and we shouldn't have because it was only the one parameter. So maybe make a note of that too. So I can see what's going on there. But here you would use the alpha, the beta, and the beta 2, just like we show here. In here's beta 1, here's beta 2, and then alpha is the e to the a. Again, length's not a part of the equation in this case. So those would be the factors. So if you created some complex model and you weren't real sure about it, you could actually plug the equation in here, and you could do e to the x exponent, and you don't even have to type it in, but you can go here and point to the alpha, and you can multiply it by, and I won't go through and do this all. You can multiply it by the major, and then take it to the B1, and then the other one to the B2, and put all that in there. And when you hit enter, this value will match or should match the prediction exactly. And again, if I put in the both ADTs and the alpha and the beta, you'd see that they'd match. And that kind of is a check. That tells you go ahead.
No, I was gonna say, no, that's good to build in that check. That's smart. I'm making that.
Yeah, that way you can be pretty confident. Well, you can be confident that you did it right, but you can also be pretty courageous in getting in here and trying out a model. Because if you see that interaction term in the bottom, I mean, that can get pretty complex. But if you don't do all that right, and then you go through an Excel and it checks, to 7 decimals, you can say, okay, we did what we thought we did. So I think that's a nice way of double checking. And again, we calculate our PCRs as we did before. Now here, or EECs, sorry, Nathan. Here I would like to point out that if you do filter by PCR or EEC or whatever your metric is, you may want to be careful to consider the class. So since you have different intersections, you could have like a multi-lane divided intersection, which might have really high ADTs. And then you might have, a rural 2-lane, let's say 3-legged intersection. I wouldn't necessarily be comfortable comparing the PCR, the EEC from one to the other without considering cost benefit, ADT, something else. And that's where we started to get into something called LOSS, which is level of safety of service or level of service safety. I forget which way the term goes. That's actually in the most recent GitHub code. It was not in our code for the example I'm showing. But if you scroll through here, you'll see that there are the calculations to calculate LOSS. And LOSS basically scores everything 1, 2, 3, or 4. and it puts them in different bins compared to its own data. So I think that's a nice way of, like, you could go look at all the 4s, for instance, and that way you're kind of comparing apples and apples, even though one's a class 23 and one's a class 22. So
you did say that is in the code, the LOSS?
it is in the current version on GitHub, yes.
Okay.
Yeah, and all of this stuff is, you could copy and paste chunks out here and put it into different versions. So I would always start with this version, and then build upon it. The examples I'm showing you today are from 2019 workshop, so I didn't want to go ahead and paste stuff in and start gumming things up. But you'd always probably want to go to GitHub as the source. It's
okay.
I try to add to it whenever I can. So, okay, so that's how you would do the intersections. And again, you could loop through all of them. And I'm noticing I'm running up on the end here. I'm okay to keep going until Nathan tells me to jump off and join another meeting. But if you guys have to go, you tell me, and I can wrap up as well. But I can show you one more version if you like.
Oh yeah, we're free. We're good to go.
Okay. Let's see. So the last example here. Now this is rural 2 lanes in Kentucky segments, but you can use the same process here that for intersections. So I'm going to delete my iteration that I did there. So imagine if you had more data associated with your intersections, you could apply this same methodology. I just didn't have as robust of a data set for intersections to show, but if you ever get into segments, this is something I think you want to pay particular attention to as well. So pointing to our folders, now I'm going into the advanced folder, rural 2 lanes in Kentucky, put the date and the year. Again, all that gets pointed to the in the output file. Here I'm just focused on total crashes for now. My class column is blank, so it won't do any loops. My ADT column and length are right there. Okay, now I did set so this is all 2-lane roads in Kentucky. It's a 20 or so. No, I'm in the wrong folder. That's what's happening. Advanced, that's what I wanted. There we go. It's a 40 megabyte file. So there are a lot of segments in here because it's all 2-lane rural roads in Kentucky and all the crashes associated with them. I'm going to run this with a couple ranged filters on. I'm going to start running it actually. This takes a little bit to run because it's such a big database. But what I'm doing here is I'm filtering between 8 and 10 foot lanes and 2 and 4 foot shoulders. So that limits our database by quite a bit. If you run it on all 2-lane roads without any filters, it's a really bad model, obviously, but it also takes a really long time to run. As it is, this takes, I think 1.5 minutes, 2 minutes to run. So, yeah.
Quick question on the size limitation. I was playing around a little bit with RStudio last night, looking at crashes, and I got an error that said 5 megabytes was the limit for inputting the data set. Is that maybe RTools, because I don't have RTools downloaded, maybe that takes care of the size limitation? Are there any limitations on the size of the data set that you can pull in RStudio?
As far as I know, no. This is again 40 megabyte file, and I'm just guessing for 8 to 10, 2 to 4. I'm probably looking at least half of the database, so 20 meg, certainly more than 5 meg. So yeah, that may have been a red herring. If you get that error and you're able to reproduce it, I'd be happy to try it on my end, see if I can figure it out.
Okay.
Again, I'm no expert at R, but I've debugged a lot of things just from trial and error. So yeah, it shouldn't. RTools, maybe, I doubt it does anything to fix that. It might depend on how you're loading the data in. Were you trying to print it to the screen?
No, I was doing the file. If you go up to file, and I was just trying to play around with it. I tried to,
Oh.
I think it's file. No, maybe that wasn't it.
You were loading it into R. Okay. I would
like to import the data set.
Okay.
And it kept telling me I couldn't do that. And so I'm sorry, I can't remember. I'm trying to remember what.
No, I think what I'm doing here instead is I'm just loading the data, pointing to the file, and
Okay.
then I read the data in using the read CSV file.
I
So
ended up doing it that way, and it worked. I just was curious what the difference was.
Yeah, I'm not sure. I don't actually use RStudio as like a GUI interface to work with the data, which I know you can, but I use more of the scripting.
Okay.
Yeah, so it could be maybe you have to pay money for to load bigger files in.
Oh, that could be.
Yeah. Okay, so I think I stalled long enough. So now again, this I think is the beauty. And Hussein, I don't know if you guys will ever get to roadway segments with this, but as we go through, well, that needs to be next then, because I think what you'll find really handy here is I have all these filters commented out because they're things I turn on and off to experiment. Mm-hmm. When I uncomment out a filter, it's actually doing two things. It's adjusting the basically it's this is like a SQL query, or if you're familiar with ArcGIS, they're like ArcGIS queries. Lane width greater than or equal to 8, ampersand, lane width less than or equal to 10. That gets applied to the database. And the other thing happens with the semicolon here. We also represent that in shorthand, LW, lane width 8-10. So put a little shorthand version of that, because we're going to paste that into the folder that gets outputted. That's right here. Now we're looking at a rural 2 lane. That's our base. Lane width 8-10, shoulder width 2-4. The beauty of this is I'm going to do a dozen or so changes of the filters. And every time we do it, each folder is going to have its new name. It's not going to overwrite the old one. And you can look at them side by side, because I don't even have to open that cure plot. And I can tell you, I think everybody in the room now can tell you that's a bad cure plot. This is showing extreme omitted variable bias, extreme drifting. We haven't done anything good. But that's understandable, because that's every rural 2-lane road in Kentucky between 8 and 10 feet and 2 and 4 foot shoulders. So you can do ranged filters like that. I find it's more helpful to do strict filters. Sorry, backspace, which I do above. And I'm going to do, so it runs a little bit faster. I'm going to jump in. All right, I'm going to look at just 9-foot lanes. I'm going to look at just 3-foot shoulders. I'm going to skip our intersections, because we have intersection crashes along the roadway segment, but they're flagged with an intersection ID. So I'm going to pull them out. So anything that is happening on an intersection, I'm going to ignore, because we do our intersection analysis separately. I'm going to skip the curvature for a moment, skip ADT, skip that. I think that's pretty good. Let's, there's a few segments with some medians in there. I'm going to pull those out too. So save and run. Now by commenting out or uncommenting the filters that I chose, it now added new things to the base filter, to the folder. So now if I go back here and look at my route, well, now look, and it's very human readable. Rural 2 lane, lane width 9, shoulder width 3, no intersection, no median. That's what's represented in here. And it's not even done running. Well, it is now. And look at that. Much, much better cure plot. Would you agree? Mm-hmm. But this is not an IODOT Hussein standard cure plot. So let's try to get to that, because that, to me, that's the gold standard. So we can do that a couple ways. One, we can filter by ADT. Now that might be a tricky piece, because you're kind of using that as a proxy for the type of not necessarily rural and urban, but whether it's a small city or a medium-sized city or something like that, where ADT may increase. I'm going to pull out our curvature. So this is only going to include kind of tangent sections with pretty flat vertical curves. I think that one's pretty good. So I'm going to run that. And notice how much faster it's going as we go on here. It's creating the folder now, and it's finished. And now look, we have no vertical curve, no horizontal curve, and it's just cascading, right? So you just enter on this. All right, that looks really good, except there's something going on here where it takes this jump. I don't want to get too classroom-like, but anyone have a guess what's happening here?
I have no clue.
This is a good thing to watch out for. It's a vertical jump in a cure plot indicates there's a huge residual. And that's similar to that 22, that EEC of 22 we saw earlier. This is usually a good indication of an outlier. There's something in the database that's making this jump dramatically. We expect, based on its ADT, and based on its surrounding and the averages of the other segments, we don't expect this many crashes, but we're jumping from, you can kind of look at the scale here, we're like almost -50 to a +50 if you shifted it down. We're jumping by about 100 crashes. So we are either over or under predicting. I think in this case, we are over predicting by 100 crashes. And that's unexpected. But just so happens I know exactly what's going on. Not that I staged this whole thing anyway, but there is a section of US 60 in Davies County. I'm sure Nathan's familiar with this, where the crashes are, it's a rural 2-lane segment. The crashes are being assigned to that segment, even though they're happening downtown in a big city in that county. They're being misplotted. It's an error in the database, the crash database, and they're just getting plotted in the wrong spot. So if I apply this filter, I will pull that route completely out of the database. Obviously, you could go in and fix the segment in the CSV, but just with a simple filter, I'm going to pull that out, run the model again, and it creates a folder now, if I expand it, called No US 60. And if I go inside there, what do we have here? Hussein, would you approve?
Yeah, that's perfect.
Yeah. So you could slice and dice this more if you want. I think if you filter by ADT, you can get this little chunk out here. But again, don't let perfect get in the way of the progress, or whatever the expression is. If you look at our metrics here, I mean, we have, okay, so our cured deviation percentage, which we want under 5, is about 6. So I think you could tweak it just a little bit more. But again, you're dealing with that trade-off where how fine do you want your model to be? We're looking at a sample size of 2,900 segments and about 225 miles and 720 crashes. So it's a really good sample size. You could tweak it a bit more, I suppose. You probably get a little benefit out of there. There's your alpha and your beta and your theta. So I think that's a pretty good one. The last thing I wanted to show you to make sure you saw how it worked is you can do the same thing. So everything we've done here, and again, notice how, I mean, if you have it all kind of prepped ahead of time, just with filtering on and off quickly, you can immediately see the benefit of what you did or the downside. I'm going to throw in here, I think I have columns for, well, I'll just look at, I'll look at our output here. And if I go to data, yeah, so this is all of our information on the segments, speed limits in here, in fact, and we could filter by speed limit, but I do have K, KA, KAB, KABC. So I'm gonna go here to, I can add, so right now we're just doing total crashes. I can also do KABC crashes, and I can also do KAB crashes. And if I want to do KA, generally we don't do just K crashes because, fortunately, there aren't as many fatality crashes as others. But the only odd downside to that is that sample sizes are too low usually to do any meaningful modeling. So usually you want to look at Ks and As to get a better model. So I added all those in. All I'm doing here is making these variables not null, not blank. And if they're not blank later on the code, it says, oh, you want me to do KABC? I'll do that. So again, just highlight everything, do a run, go over here to our model. Now it will delete everything in a folder and rerun it if it exists already. But I mean, and look, what did we say? It was 225 miles, 700 crashes. That's how quickly it ran. It's finished. So we have our original model, which was all crashes, which we've already seen. We have our KA model, our KAB, and KABC. Nathan, I realized I'm demonstrating how easy it is for us to do this. And now I won't be able to tell you it's going to take weeks to give you that data, right? I don't know if I lost Nathan or not, but anyway, it is pretty easy to do these and to do them quickly. So you can dive into one of the folders and see there's the cure plot, and then you can jump out and see if you made improvements on the cure plot. And it looks like those are a little bit better. Yeah. So now filtering by severity, you can even improve the model. And then this model might be more meaningful, as Nathan was saying earlier. You might weight the EECs or the PCRs from these models and add them together or weight them together so you have kind of, well, here's our EEC for the more severe end and here's our less severe end. So yeah, any questions on that process?
No, that's pretty fantastic, actually. You're right. R is crazy fast, so it takes what would take lots of time to do manually and does it in a fraction of the time. So I'm impressed with R. My background is I come from part of the agency that did the travel demand models. We did all of the travel demand models in R.
Oh, wow.
And so I see so much efficiency with R coding and the ability to process data now that I'm in a new part of the agency using that, but I'm not really great at R scripting. So I can generally take a script and edit it to do the things that I need to do, but I'm not good enough to build a complete script all on my own. So I'm always interested in ways that people are using these kinds of scripts or agencies are using them because I think it's really fast, it's really efficient, and the code itself is the documentation. So oftentimes we aren't really great at documenting the process. The beauty of this is R is the documentation. If you run it a million different ways with that code, it'll run it the same way every time.
Yeah, no, and you're absolutely right. And I imagine someone who's actually more versed in R could probably get there and make it optimize it even more. But it's pretty fast. It's fast enough, I think, for most of what we do.
You can answer questions pretty quickly, which is nice. I mean, sometimes we get asked a question, and if we have to do it through manual methods, by the time we get an answer, we've already moved on to another question. So using R is a nice way to give a quick, fast response that helps point us in the right direction. It may not be the perfect answer, it may not include every variable, but I think it helps us get pointed in the right direction and moving from there.
I certainly agree. And I think it's also nice that the output is set up as a good documentation too. If you're careful,
you set that up. Nice.
Yeah. And again, it's all about being quick and efficient. So I'm sure others can make it even more efficient. Yeah, I'm happy to answer more questions or point you up in any other directions if we had any.
Well,
Hussein,
I my IT person to download the RTools. So I didn't mean to interrupt. Maybe Hussein has more to answer, but I was just going to say for us on our side, once you share some of the exercise scripts, that'll give us a better feel for how best to run this. And then, but like I said, until my IT person updates my code, the folders, I'm not sure that I can run this yet.
Okay. Yeah. And I'm happy to do phone call or screen share if you try to get set up and you're having slight difficulty. I know, Hussein, we hit issues at TRB, sitting at a laptop going through it. Sometimes they're just minor little things like that just gum something up. I've seen
because
a lot.
I think we were just trying to use the segment codes and modify that for intersection. We forgot some of the small things that we were not including, so that was creating us some problem there.
Right, and I think since then we've actually gone through it a lot slower and created this test example here, which does cover intersections. So
yeah,
I will.
Great.
I will share. I can share exercise 2 and the test. Nathan said he jumped off. I don't know if he got back on. I don't think I can share the Kentucky data because it has
just the test. Just it's enough for us to see the structure and the variables that are being pulled in and spit out. So yeah, we really appreciate that.
Yeah. Since we didn't anonymize our data like Iowa, Hussein, is it okay if we share the Iowa CSV?
Yeah,
here?
I think it doesn't have any identifying information on that. It's just data.
Yeah. Okay. Yeah, I'm happy to share basically the CSV and the R code for both of the first 2 examples. Yeah, and I think now you will have to change your path. At some point I did go through and I wrote some code copied and pasted some code where it would look in the folder that the R code was in. So as long as the R code and the input file were in the same folder, you could just run it more generically. I never
set ours up. So when we in the R properties, we removed the path and we just and then we place copies of the R shortcut in our folder, and then it just works directly from the folder that the R shortcut's in.
Okay. Well, I'd be very interested to kind of know how that works, because that's the one frustrating piece about this is if I work at home or at the office or on my laptop, I constantly have to change the paths. At one point I was putting everything in the users folder, but that, that's less helpful too. So streamlining that would be pretty handy.
Sure. Yeah, we can send you I can send you a quick response and show you what we do and how we do that.
Yeah. I do know that VHB is also working with this same base code to do some network screening as well. So, at some point, maybe we could put together a little working group of users and we can kind of share resources.
Oh, that'd be awesome.
Yeah. I may share this video with them and see if they have anything to add, but I covered everything on my notes, I think. Happy to address anything else if folks have it, but.
Well, we just want to say huge thank you, because this is really, really good stuff, and I'm excited to play around with this. I think we can definitely make quick use of this. All of our data, and just so if you're looking to test this on other state data, all of our crash databases are available on our FTP site. So that's something I can share with you too, because I'm certain that I'll have questions and I'll want to follow up with you if you have time to answer those. But I would just throw that out there that if you're looking for other data sets to play around with, we have about 5 years, or maybe actually about 10 years worth of crash data available on our FTP site. I think they're in shapefile format, and then we have access databases as well.
Oh wow! Okay. Yeah, we're not that unfortunately lucky enough to be able to share like that. We're getting more access, but there's still privacy issues where we can't share.
Our data is anonymized, so plus it's old, so there's trade-offs. You guys probably get your data much quicker. We're always a couple years behind. So the most current data set that we have is 2017. We have a 2018 preliminary data set, but it's not been QA/QC'd. So yeah, there's definitely trade-offs. We wish we could get the data faster, but we also we spend a lot more time coding it. And so yeah, there's always trade-offs, but I'll share the link with you and you can take a look.
That's an interesting approach to kind of delay the data by a few years, but really scrub it and anonymize it and improve it, I assume, too. Are they doing QC checks?
They do QA/QC on the location because we spatially locate it so that it's available in shapefile format. We post it to our, we have a tool called TransGIS, and so all of our data is available on visually through our tool, and then we make the data available through our FTP site to anybody else that wants to take a look at it and mission mash it any way that they want to. So the QA/QC does take a little time. That's mostly for spatial, and you know, we're hoping to have the 2018 data set by the end of June, which is really late, but that's one of our biggest issues is we're always so far behind with the data.
Well, something we've seen in Kentucky is if you're looking at it at, you know, 5-year chunks, I mean, you really don't need, you know, the latest, greatest. I mean, 5 years, you get the average over that. That's pretty good. You add a year, take off a year. I mean, it doesn't fluctuate that quickly unless it's something major.
Sure.
So I would actually rest assured that you have much better access and better quality control data. That's probably better than more timely data, I would say.
Well, it's kind of an issue when we're you know, looking for safety projects through our arts program. You know, we get a lot of pushback because, you know, we know that maybe a fatal has happened at a location within the last couple of years, but it hasn't made its way into the database, so it's not eligible to be in an application. So that's kind of the downfall. For example, you know, recently we had a location where we had 3 fatalities in the course of about 2 years, and we still actually don't have that data set yet. So that's kind of the downfall.
Yep.
No, in Kentucky, we run into that even with our timely data because it's still, our screening is a year behind. So, but, you know, the safety world, you got to deal with it.
Yeah. Well, again, we're really excited to try this out. We have a project where we are looking at all of the signalized intersections on state highways in one of our regions and trying to do collect the fundamental data elements enough that we can run the HSM predictive piece on them, and then this code would be really useful to do some additional analysis with that. So we're real excited.
Yeah. Well,
without this code, we'd be doing it in Excel.
Yeah. Oh, fantastic. And I'm eager to hear how it works and your experiences, and see if you can get better cure plots than Iowa. That'd be.
Well, I'm interested now in going back and looking at our freeway stuff to see if we could do something a little different with the code. I'm not sure. We had an intern working on it, and he knows R, so he might have done his in R as well. But I'm interested to touch base with him and see if there's any improvements that we can do as a result of your code.
Yeah, well, it's all open and shareable, so feel free.
Thank you. Appreciate that.
Yeah.
Good. Nicely done.